My name is Michael Pan. I'm a Senior Director of Software Engineering in Synaptics. Today I'm very excited to introduce everyone our new product line. It's called SL2610. As our previous generation, SL2610 is also a Linux-based A-class 2-core 855 processor. And with this processor, what I'm going to demonstrate is a list of capabilities this particular device can do. So on this, behind us is our first demo. So this is the MI SDK, Managed Integration SDK from Amazon. So in this chipset, 2619, we integrated Amazon's MI SDK. What MI SDK brings us is that unified translation layer between Wi-Fi connectivity product with other radio connectivity products. So today in our household, you have multiple smart devices, IoT devices, whether it's a light bulb, it's a smart door lock, or smart plug. You have various apps from different vendors to control them. With the managed integration, you have one app to control them, whether it's Zigbee, Z-Wave, Matter, or OpenThread. So on this side, you can see I have two devices that's paired to my hub device. One is the light plug. The plug, you can, with a simple click, the AWS sends a command to my hub device. My hub talks to the plug in a Zigbee protocol, which turns off this lamp. Of course, I can turn it back on, and some other devices have multiple capabilities. For example, this particular light bulb, smart light bulb, that has two capabilities. One is on-off, as we just showed earlier. Additionally, it has a brightness adjustment. So I can switch the brightness. You can see that light bulb just get brighter. So this is the MI SDK, which helps us to manage all the IoT devices in your household. This demo really showcases how powerful our AI capability is on 26 family. So the movie is played, and the movie is rendered on CPU. This is a HD video getting rendered on the CPU. This original subtitle is in English, so we're extracting that subtitle from the video clip. We're translating that subtitle to a desired language in real time. And we're overlaying translated subtitles at the same time. So you can see the original subtitle on top and translated subtitle at the bottom. And today you can see English on top and Spanish at the bottom. Actually, in the same device, we loaded 3 different language models. They're Hindi, Chinese, and Spanish. And if you wait until next clip, it will play next video clip, but next time it's going to translate the English subtitle to either Hindi or Chinese, depends.
And this is in real time and offline?
This is real time and offline. As you can see, I have no network connections. There's no Wi-Fi connectivity on this particular device. It's playing a video which is loaded on the eMMC flash drive, but it is able to do the live translation, real time. And we're able to do 100+ languages in pairs to translate in between them. Okay, so this is the translation. People maybe are asking, you can do the translation. Do you have speech to text? Do you have text to speech? Of course, this is our speech to text demo. The speech to text model we have is we support both Moonshine and Whisper. So what we have demoed today is Moonshine. So it takes 2, 3, 5 seconds of audio. It's able to transcribe that audio into text. If we combine this demo with the other demo, so whatever I speak in English, it transcribes to English. It then can translate it to any desired language afterwards. Now, if two people, they can talk to each other even though they speak different languages. So I'll do a quick demo right here.
And this is all offline?
This is also all offline, on the edge.
Okay, so in this demo,
Hey, welcome to Synaptics Tech Day.
drive all our system including this.
You can see that is getting translated, transcribed. The whole transcribing took about 1 second, but my sentence spoke is about a little bit more than 1 second, which means I can catch up in real time. This one shows how large language model can be executed on 2610 family. And we load this with the Gemini 270 million model. So this is a Gemini model running completely offline on the edge. So here we can ask any questions to this. So tell me about SL2610. It gives you this ChatGPT-like. So I preloaded this model with a paragraph, which the RAG model will take that, try to understand that paragraph. When I ask a language in a natural language way, it can understand, dissect my question and give the best matching answer, which is what is this demo is showing. Other than the live chatting, we also have pre-arranged questions, which user can just click the button and get additional information. Typically, you see this use case in appliances, where people doesn't know how to use a particular appliance. They can ask questions, or they can have few menu selections that gives you the appropriate answers. On this particular model, we're just showing our CPU versus NPU capability. So you can see the same model is running. This exactly same model is running. But on the right side, you see this bar, CPU usage is much higher. On the left side, you see the CPU usage is lower. This is the same YOLO VA model that is running. So the performance is more or less the same, but on the left side, since the AI model is running on NPU, you can offload the CPU, which can do additional timing and processing. Okay?
So it's heterogeneous AI acceleration.
Correct. So on this one, we're only showing the same model, YOLO VA model, that is running on NPU and that is running on CPU. So on this side, you see it is running on CPU. That's why CPU load is much higher. On this side, we're running on NPU. That's why you see on average, CPU load is much less. And this is the reason we can show the same model can either run on NPU or on CPU. So this is just the side-by-side comparison that we're showcasing this. As we know, 2610 has 3 different sub-modules, which are M3 that does the security core, M52 that runs our RTOS, which is the MCU domain, and we have an A55, 2-core A55, that's our MPU domain running Linux.
Can you show them here? So which one are you running on batteries now?
So the entire system is running on battery. Everything. So M52, that's your M class. And then you have your CPU, which is your A class on top. So what you're seeing right here is the battery drives the entire board. The board is, through the MIPI interface, is connected to a display panel. So right now you see a gray-scaled panel. That's driven by RTOS, MCU. M52, System Manager, which runs right here.
That's a Cortex-M, so
Cortex
you'll have hybrid.
M52. Now I switch to A55, which A55 drives GPU. The GPU renders this whole color screen. Every 15 seconds, I'm going to rotate between NPU and MCU. You can see how fast we can rotate between the 2 subsystems. And this shows how much power it takes to drive the entire demo. And if you use your finger, touch this, you can see there's no temperature, almost no temperature at all. That shows minimum power it takes. Unlike our previous generation where we have to apply a heatsink. This one can go without heatsink, which makes perfect for IoT
Are you
device.
in a low power mode?
Once we're in MCU, we're in a very, very power saving mode. On the NPU side, that's your high power domain because Linux demands more power. So this demo shows we can transit between the two subsystems without much of a display delays.
And is this a completely new architecture in terms of the low power mode?
Yes. So M52, using M52 as a system manager is a new architecture design we added with the 2600 family. And we will carry this same design in our future generations. This M52 really gives more power to control the power, more ways to control the power, because the system manager can rely on RTOS, which consumes less power compared to.
How much power comes from two little AA batteries? It's not a lot, right?
Yeah, the two AA, that's your 3-volt normal, like, I don't know exact power number, but these two batteries, if we continue to run this today while we're doing this, it lasts from this morning, it's about 6 hours running this. But
And
your typical IoT...
Including the AI engines?
The AI engines, the same AI engine which I showed earlier. So it's the MPU that is Torque MPU running inside this system, 2600 family.
And here you have some partner boards already?
Yes, so we have various partners from Brain and Technician. They're taking our 2610 chip and come back with their own SOM design and their OEM ready designs. So these are the things that you can, this is from Grain.
All right. What is the software story you would like to highlight in terms of, it's such a nice open source philosophy you have in the company, right?
Yes, so previously we introduced the word going to the Yocto. So we really benefit from this. So it is amazing. Team has done an amazing job. This chip, everything you saw right here, exactly 1 month ago, September 15th, we just got the chipset back. So within a month, we're able to bring up the chip on our PEK development board. We're able to bring up the chip on our reference development kit, which is the Astra Machina boards. And we're able to get the SDK ready. If you check our GitHub, today we released Astra SL 2.0.1, which is specifically for our 2600 family. And everything you saw, today's demo, they're running. All these work we have accomplished in one month. I'm super proud of my team. Our team members can deliver all these, both from hardware team and software team.
How did you organize the team?
So we have we're an international company, so we have development centers around the globe. So we have a headquarters in San Jose. We have our BSP team, security team, and OS team, kernel team in Shanghai. We have our AI team, display team, and graphics team in Bangalore. We have our AI architect in Switzerland, Paris. So we're everywhere. We have our solution designers in Irvine. We have our application engineers everywhere around the world. So we're really consolidating all our engineering power together to make it live. And this is what we saw today.
Is it true that software engineers enjoy more working in open source?
I do think so. At least that's my personal preference, because we can quickly adapt a particular open source. For example, the Moonshine. It's a model that we can quickly quantize on our MPU hardware architecture and showcase its capability on our hardware. If everything is closed sourced, we won't be able to deal with that.
And the NPU has this subsystem with a RISC-V.
Yes.
Is it fun to work on that area too?
Yes. So this generation of it, which is our new generation of MPU called Torque. Inside the Torque, we have a general purpose RISC-V core, which is partnership with Google. So Google R&D team is actually working together with Synaptics to design that part. So that general purpose of the core should be able to allow us to deal with the future models in case next generation of an AI model, who knows what, right? We have the convolution, now we have a transformer, and next generation may have other operators we don't support in our hardware today. But that general purpose RISC-V core should allow us to execute those unknown operators on the same NPU hardware. And that's the day we're looking forward to.
What is the feedback you're getting from customers, from partners, or people in the open source community? What are they saying about what's happening right now? Because it sounds like you are pioneering a new kind of way of doing edge AI.
So we want to make this easier for AI community or edge device community. So not too many edge device communities, they have their open source components, but they're not able to showcasing AI running, edge AI running on their device. That's what we're hoping to bring to this era. We want to show the complete readiness of the SDK with the pre-bundled AI application completely open source, so they can quickly modify according to their needs and make that product available to the market. That's our goal.